My name is Mohammad Ali Amini. I'm technical advisor for mobile telecommunication industry. In this presentation, we will try to cover the main topics about the 5G NR overview and the main difference between the current 4G network and 5G technology. In this presentation, we will talk about what is the 5G NR, NR 3GPP time plan, non-standalone and standalone deployment option, centralized and distributed unit deployment option, LTE versus 5G NR difference, and the last section we will discuss about the new feature which is added in the 5G technology like multiple numerology, millimeter wave, beam management, LDPC polar, and SDAP layer. But what is a 5G? 5G is the new generation of radio system and the network architecture delivering extreme broadband, ultra robust, low latency connectivity and massive networking for the Internet of Things to enable the programmable world which will transform our individual lives, economy and society. The biggest difference between the 4G and 5G design requirement is the diversity of use cases that 5G network must support as compared to 4G network that were primarily designed for the single use case of delivering high-speed mobile broadband. In this picture, we showed the main use cases of this 5G technology like enhanced mobile broadband, ultra-reliable low latency communication, and massive machine type communication. If I want to explain some short discussion about the EMBB, I can say aim is to meet the demand for an increasingly digital lifestyle and focus on services that high requirement for bandwidth, such as high definition HD videos, virtual reality, and augmented reality. Actually, we can say EMBB represent an evolution of the mobile broadband service offered by 4G, also generally involve human accessing multimedia chats, services and data. Finally, we can say improving the user experience for existing application and support the introduction of new application. About ultra reliable and low latency communication, we can say aim is meeting the expectation for the demanding digital industry and focus on latency sensitive services such as assisted and automated driving and remote management. We can say application associated with URLLC communication tend to have only moderate throughput requirement but require very high reliability and very low latency. Maybe you will ask, what is the reliability, meaning of reliability? Reliability means packet delivered correctly within a certain probability within a certain latency bound. So the meaning of reliability is that. And the third use case is massive machine type communication. The aim will be meeting the demand for further developed digital society and focus on services that include high requirement for connection density such as smart cities and smart agriculture. So in general, we can say 5G NR has been specified based on the requirement of these use cases. So you need to achieve the higher throughput, more than 10,000 time traffic, low latency, ultra reliability, zero mobility interruption, and the battery life, and also ultra low cost for the billion connection between the devices. So for the requirement of these use cases, we need to achieve these criteria and KPIs. Here we showed some use cases for this URLLC, EMBB and EMTC like broadband and media everywhere, like live TV at scale, event platform, on-demand anything, a smart vehicle and transport like autonomous vehicles, connected bus stop or connected cars. We can talk about human-machine interaction, example like smart houses, smart shopping, immersive gaming, and also augmented reality. Also, we can talk about the sensor networks as example, like agriculture environment, smart buildings and cities, and critical control of remote devices like factory automation, real-time process control, or remote surgery. And the final example will be about the critical services and infrastructure control like public safety and mission critical utility. So if we talk about, as far as the 3GPP is the main concern, so the 5G RAN requirements, it is defined in the 3GPP 38.913. In below table you can see the requirements of each KPIs, which is shows here, like performance measure and the requirement like peak data rate, peak spectral efficiency, spectral escapability, bandwidth, and so on. For an example, I put it the criteria for the EMBB use cases and the main KPIs, which is shows here, like peak data rate, how much should be in the peak spectral efficiency, spectrum scalability, bandwidth, control plane latency, user plane latency, user experience data rate, and EMBB extreme coverage, which all is defined in the 3GPP releases. So here in this page I put it the evolution of communication from 2G to 4G to 5G. As far as our main concern is related to difference between the 4G and 5G, I will put it here, the difference between the 4G and 5G. Also about 3GPP releases, which the 4G started with release 8 and 5G started with release 15. About use cases, which we already talked about, the channel access, both are OFDMA, but in the 5G we have the modified OFDMA. About the bandwidth, which is LTE, started with 20 megahertz, but in 5G we have up to 2 gigahertz. In the services, both are in the PS domain. About architecture, which is distributed in LTE, but in the 5G we have new concept like slicing, coexisting, and cloud. About downlink speed, in release 8 in LTE we reached to maximum throughput 300 megabit per second, but in a 5G we reach more greater than 10 gigabit per second. And about the latency, which is in LTE it is around 10 milliseconds, but in 5G will be less than 1 millisecond. 3GPP releases, as I said before, NR started with release 15 and is divided by two phases, phases 1 and phases 2. Phases 1 is related to release 15 and phases 2 is related to release 16. Also we can say in release 15 we have two drop. One of them is early drop, which is related to non-standalone concept, standalone, and some functionality, air interface, and so many of topics. But in the release 15 we have one late drop also, which is it was about second quarter of 2019, which it was talk about the 5G core and enhancement. In release 15 the main focus was about the NR phase 1, safe evolution, unlicensed spectrum, vehicle to everything, enhancement of the URLLC use cases, and also NLT NGC. Also it was around some potential like positioning, also enhancement support for network relying wireless backhaul also. In release 16 the topics was related to interworking with non-3GPP Wi-Fi, enhanced support for above 60 gigahertz, enhanced massive machine type communication, and enhanced about the MIMO and carrier aggregation in release 16. But in release 17 it was related to 5G enhancement like NR MIMO, NR coverage enhancement, RAN slicing concepts, and NRQS, and finally enhanced vehicle to everything and services. So as a summary we can say release 15 is related to 5G phase 1, release 16 is related to 5G phase 2 and URLLC use cases, and release 17 is related to 5G enhancement. So as a generally, and For the NR key design, critical and principal, we can say into 5G should provide enhanced mobile broadband plus new services. Support for very low latency is one of the important components. A single solution for all spectrum. There will be frequency dependency, but a starting point in the same. An interconnection and coexisting with LTE, which we will discuss in the non-standalone deployment option. And forward compatibility, a future-proof design. About the forward compatibility, we can talk. What is the meaning of forward compatibility? Actually, the possibility to extend the radio access technology with new capabilities and new technology component with retain support for legacy devices actually is the meaning of the forward compatibility. And the final is related to ultra lean design. Ultra lean design or lean carrier, which is minimizing the network transmission, not directly related to user data. Actually, in current LTE, as you know, RS is always on, but in the 5G NR with ultra lean design, no need RS will not be always on. It will be minimize always broadcast system information, so there will be benefit for using the lean carriers or lean design. It will be the enhanced network energy performance, higher achievement data rate also. So those are the benefit of using the ultra lean design in the 5G network. And the final, we can talk about the beam design, also beam based design technology. If we talk about the NR frequency ranges, we have two types of frequency ranges is defined in 3GPP. One is sub 6 GHz range, which is called FR1, frequency range 1, and the millimeter wave range is called FR2. The exact frequency range is mentioned in this table, which you can see. The FR1 is it will have started from 4 GHz, around 4 GHz to 6 GHz, and FR2 it will start from 24 GHz to 52 GHz. FR1 support channel bandwidth from 5 to 100 MHz. FR2 support channel bandwidth from 50 to 400 MHz. FR1 supported FDD, TDD, STL, and SUL. But FR2 supports only TDD. So this is the one of the main and important things which you should know about the FR2. Let's talk about the non-standalone and standalone deployment option in the 5G, and you will understand the meaning of this picture after explanation. A standalone NR-based station provide connectivity to the 5G core network. If you have in your network, you have 5G core, so you can deploy your 5G as a standalone. So in this case, your user plane and control plane will be directly connected to your 5G network. So this option will be the standalone option. Second, if you are using with your current LTE network and you will use the EPC current LTE core network, you need to have the non-standalone option. In this case, your control plane of the 5G NR will go from the LTE node B to the current core network, current LTE core network. As you can see in this picture also, you can see the control plane and user plane for the 5G NR. It will go from the LTE